So, question number 25 is on your screen. A first order reaction has a specific reaction rate of 10 to the power minus 2 second inverse. How much time will take it for 20 gram of the reactant to reduce to 5 gram? So, this question is come from your chemical kinetics of class 12 NCERT. So, now we are moving to the solution part. So, if you see they are giving this is first order. So, what is the formula for first order T half? That is T half is equal to 0.693 by K. Now, what you have to do, see how much time it will take from 20 gram of the reactant to reduce to 5 gram, and they give you the reaction has a specific reaction rate of 10 to the power minus 10 seconds. So, this is nothing but this is the value of K. So, 0.693 by 10 to the power minus 2 second. Now, see this is 20 gram. If I am run down T half, so this amount getting half, what is the half of 20? That is 10 gram. Now, again half of this 10 gram is 5 gram. So, this is nothing but this is T half. So, from 20 gram to 5 gram, how many T half is getting? We got 2 T halves. So, what we do here, T half is equal to 2 into 0.693 divided by 10 to the power minus 2. So, we have to solve this part. So, if you see here it will be go up. So, here coming as 2 into 16 9.3. So, if you multiply this one 8 into 1 into 138.6. So, if you see the option number 1 where is 138.6 second is the correct answer of question number 25. So, now we are moving to the next question, that is question number 26. So, question number 26 is on your screen. Which one of the following pairs of species have the same bond order? So, now we are moving to the solution part. So, if you see, so they ask you the bond order. So, for that I will give you a simple trick here. If this types of question they ask, so rather than you have to calculate, you first calculate the total electron count. If it will seem then your bond order also same. So, if you see the oxygen, the valence electron oxygen is not valence electron, the total electron, that is 8 into 2, it is coming as 16. For this nitrogen it is coming as 7 and oxygen is 8, and this positive means it is minus 1. So, it is coming as 6 or 7 plus here also coming as 14, here 16 and 14. So, this is not your correct option. Now, for carbon it is coming as 6 and nitrogen as 7 plus 1. So, it is coming as 14. Now, for carbon monoxide, so carbon is 6, oxygen is 8. So, this is also a 14, right, 12 14. If you see for nitrogen it is coming as 7 into 2, that is 14, for oxygen 8 into 2, that is coming as 16. For this one carbon is 6 plus oxygen is your 8. So, it is coming as 14, nitrogen 7 plus 8 and it is coming as 15. So, here see the total electron count is 14 and in this species total electron count is 14. So, for option 2 the bond order is also same for Cn minus and CO. So, in this way this small, it is a trick, this is not a concept. Okay. So, with the help of this trick you can easily solve the answer of these types of question. So, option number 2 is the correct answer of your question number 26. Now, we are moving to another question, that is question number 27. So, question number 27 is on your screen. So, in which pair of ions both the species contain sulfur-sulfur bond? So, this question is come from the p blocks element of your class 12 NCERT. So, here the correct option, your option number 1 is the correct answer of this question, that is question number 27. So, now we are moving to the another question, that is question number 28. So, question number 28 is on your screen. So, concentration of Ag plus ions in a saturated solution of Ag2C2O4 is 2.2 into 10 to the power minus 4 mole per liter. So, solubility product of Ag2C2O4 is. So, now we are moving to the solution part. So, this question is basically come from your equilibrium chapter of your class 11 NCERT. So, if you see your Ag2C2O4, when it will be dissociate, it will be give you Ag plus and your C2O4 2 minus. So, it will be balanced like 2 Ag. Now, for this I am considering his concentration as S and it will be 2S. So, in question what they giving? They give you the 2.2 10 to the power, that is the Ag concentration they given. It means twice S is equal to 2.2 into 10 to the power minus 4. What happened with S? S equal to 2.2 into 10 to the power minus 4 divided by 2, and your answer it will be end up with 1.1 into 10 to the power minus 4. Now, for Ksp, for this reaction it will be 2S whole square into S. So, what is the value for 2S? That is 2.2 into 10 to the power minus 4 whole square, and for S it will be 1.1 into 10 to the power minus 4. So, it will be 8 here, 8 minus 8 minus 4. So, it will be end up with into 1.1 into 10 to the power minus 8 minus 4, it will be 10 to the power minus 12. So, if you see this 4.5 and your 2.42, it will automatically cancel it out. So, if you solve this part, your answer is come as 5.3 into 10 to the power minus 12. Why I am cancelling this 2 and 4? Because see here 10 to the power minus 11 is given, here 10 to the power minus 8, but in our answer it should be a 10 to the power minus 12. So, 5.3 into 10 to the power minus 12 is the correct answer. Now, if you see among your options, option 1 and 3, option 3 it will be the correct answer of your question number 28. So, now we are moving to the next question, that is question number 29. So, question number 29 is on your screen. So, ionic mobility of which of the following alkali metal ions is lowest when aqueous solution of their salt are put under an electric field? So, now we are moving to the solution part. So, if you see here, they are asked about the ionic mobility, and this ionic mobility is inversely related with the hydrated size. When size is bigger, the mobility will be decreases. Now, if you see li na ko rab se faryad. So, this is the normal trend, li na ko rab se faryad. So, if you go down the group, what will happen? The size increases. But if you consider a hydrated structure, suppose this is my lithium, this is smaller, and this is my cesium, and if I am going to draw a hydrated structure of this, So, these blue colors are water molecules. So, this is nothing but this is lithium and this is my cesium. So, if you see your lithium, that is the water molecule will more occupied. So, this is the larger hydrated size if we compare with cesium. So, when I am going to consider the hydrated structure or hydrated forms, this trend is getting reverse, like lithium is greater than sodium, then rubidium, then cesium. So, this is the hydrated structure trend. So, if you see lithium having a higher hydrated size, so what will happen? The ionic mobility of lithium is going decreases. So, if you see the ionic mobility order is just reverse, means lithium is less movable than your cesium. So, they asked about the lowest. So, which one is the correct option? Option number 3, that is lithium, which is the lowest ionic mobility, and this is the correct answer of question number 29. We are moving to the another question, that is question number 30. So, question number 30 is on your screen. A gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atm from an initial volume of 2.50 liter to a final volume of 4.50 liter. The change in internal energy delta U of the gas in joule will be. So, now we are moving to the solution part. So, this question is basically from your thermodynamics chapter, okay, and from your class 11 NCERT. So, what is the formula for delta U? Delta U is equal to Q plus W, but for an adiabatic process, this Q is equal to 0. So, delta U is equal to W, and W is nothing but minus P del V. If you put the P value, whatever P they are given, 2.5 minus delta V is 4.50 minus 2.50. So, minus 2.5 into this is coming as 2 atm per liter. Now, if you see this term, that whatever answers we are getting, that answers should contain a negative sign, but in the options, option number 3 and option number 4 having the positive sign. So, these are not the correct answer. Now, if I am converting into a joule, so 2.5 this part, if I am converting into a joule, so it is coming as minus 5 into 101.3 joule. Okay. So, if you see this multiplication is always greater than your 100, means see this is the more than 100, right. So, whatever multiplication we are getting, that value is more than 500. So, if you see in the options, only option number 2 is given, which is as a 505 and here 500 joule. But in option number 1, see if this is 100, then we can say that option number 1 may be correct, but this value is more than 100. So, definitely that option number 2 is the correct answer of this question, question number 30. And if you solve also, the value is coming as 505 joule. So, this is the correct answer of this question number 30. So, now we are moving to the another question, this is question number 31. So, question number 31 is on your screen. The reason for greater range of oxidation state in the actinides is attributed to. So, this question is come from D and F block element of your class 12 NCERT. So, now we see the solution. So, greater range of oxidation, the main reason, see first one is actinide concentration, no, that is not the correct option. CF 5F CD 7S levels having a comparable energies. So, this is the correct reason that F block elements they show the greater range of oxidation states. option 3 and option 4 we can neglect it out. So, option number 2 is the correct answer of your question number 31. So, it is a direct statement which is given from your D and F block element of class 12 NCERT. So, now we are moving to the another question, that is question number 32. So, question number 32 is on your screen. The most suitable method of separation of 1:1 mixture of ortho and para nitrophenol is. So, this question is coming from your class 12 NCERT from the general principle of organic chemistry. So, if you see the option number 3, that is the steam distillations, we are basically used to separation of 1:1 ortho and para nitrophenol. So, this is a direct question from your NCERT. So, option number 3 is the correct answer of your question number 32. So, question number 33 is on your screen. So, the correct order of the stoichiometries of AgCl formed when AgNO3 in excess is treated with your complex, that is complex are COCl3.6NH3, COCl3.5NH3 and COCl3.4NH3 respectively is. So, now we are moving to the solution part. So, if you see in this question, first you should know how to convert these formulas into structures. Like for the first one, that is will be CONH3 whole 3 CONH3 whole 6 and it will be end up with Cl3. For second one, CONH3 whole 5 into Cl and Cl2 it will be an outside. Now, for the third one, CONH3 whole 4 Cl2 and 1 Cl it will be outside. Now, this one is react with 3 moles of AgNO3 and it will be end up with 3 AgCl plus CONH3 whole 6 and this Cl it will be replaced by this NO3 whole 3. Similarly, this one when it is react with 2 moles of AgNO3 it will be end up with 2 AgCl plus CONH3 whole 5 Cl NO3 whole 2. Now, similarly, third one when it is react with 1 moles of AgNO3 it will be end up with 1 AgCl plus CONH3 whole 4 Cl2 and outside it will be NO3. Now, if you see the first one it will be formed as 3 AgCl, in the second one it will be formed 2 AgCl and in third it will be formed as 1 AgCl and they asked you the correct order of stoichiometrics of AgCl. So, 3 AgCl come first, then 2 AgCl, then it will become as 1 AgCl. So, if you see among your options the second option that is 3 AgCl, then 2 AgCl and 1 AgCl is the correct answer of your question number 33. But in examination you no need to solve whole part. If you see in the first one that is Cl3, how much is there? 3 of Cl will be there. So, the similar quantity of AgCl will form, that is 3 AgCl. In the second case also outside entity 2 Cl is present, so similarly 2 AgCl will be produced. In the third case also 1 Cl is present in the outside entity, so 1 AgCl is produced. So, just concentrate on the amount or the stoichiometric what is given on the outside entity. So, now we are moving to the next question, that is question number 34. So, question number 34 is on your screen. Correct increasing order for the wavelengths of the absorption in the visible region for the complex of cobalt 3 plus is. Now, we are moving to the solution part. So, this question is basically asked from your coordination compound of your class 12 NCERT. So, first of all you have to see that E energy, that is equal to Hc by lambda. It means E is inversely proportional to lambda, means whoever having the higher energy they having the lower lambda, that is the lower absorption. Now, see the ligands, ethylene diamine, then your NH3 and water. So, this is the order of the ligand, means this E and this is a bidentate ligand. So, when ethylene diamine is there, the splitting will be more, NH3 this is the splitting, and for water this is the splitting. So, when this splitting will be more, that is the energy gap is more, your lambda value is automatically decreases. So, that this ethylene diamine, that complex will be the lower value of this absorption value. So, if you see this is the order here, but it is not coming first one. In this if you see, this is showing a higher energy order, so this is not follow. If you see option number 3, that is also not follow. If you see in option number 4, ethylene diamine having a lower energy, then your NH3, then your water. So, this is the increasing order of the absorption in the visible region. So, option number 4 is the correct answer of your question number 34. Now, we are moving to the next question, that is question number 35. So, question number 35 is on your screen. Which one is the most acidic compound? So, now we are moving to the solution part. So, if you see they are asking you acidic compound. So, for acidity you need a electron withdrawing group, means electron withdrawing group is directly proportional to the acidity, and electron donating group is inversely proportional to the acidity. Now, if you see here only OH is present, here see NO2, that is your electron withdrawing group is present. So, this may be the answer. If you see the option number 4, that is not possible because CH3 is your electron donating group which not favor the acidity. So, this is also not possible. So, option number 2 and option number 3, if you see here only one electron withdrawing group is present, but in this case we have a 3 electron withdrawing groups. So, electron withdrawing group is directly proportional to the acidity. So, the option number 3, that is option number 3 or answer number 3 is the correct answer of your question number 35. That is option number 3 is the more acidic compound.
In bougainvillea, thorns are the modifications of adventitious root, stem, leaf or stipules that we have discussed in the chapter morphologies of the flowering plants. So, what is the modifications which give rise to thorns in bougainvillea?